Today, we're doing something a little different.
Mm-hmm.
Usually, we look at the results of technology, how it changes markets, how it affects your workflow, all the shiny new tools. But today, we are popping the hood.
We're looking at the engine.
We are looking at the engine.
And it's an engine that, well, most people are currently driving at 100 miles an hour without having the faintest idea how the combustion actually happens.
That is the perfect setup. We're talking about generative AI, but not the top 10 ChatGPT tricks version of it. We're basing this discussion on writing AI prompts for Dummies by Stephanie Diamond and Jeffrey Allen.
Right.
And I want to be clear right off the bat, despite the title, this isn't just a basic instruction manual.
Yeah.
It's essentially a treatise on what they call the human technology partnership.
It really is.
Yeah.
The authors make this compelling argument that you just can't effectively prompt an AI. You can't get high-quality output unless you understand the fundamental mechanics of the machine you're speaking to.
Right.
If you treat it like a magic 8-ball, you're going to get vague answers. But if you treat it like a neural network with specific limitations and, specific processing styles, you become a pilot.
So that's the mission for today. We're going to deconstruct the flavors of AI. We're going to look at the math behind the thinking and get into the specific mechanics of text, image, and audio generation.
Feels good.
But first, let's start with this concept of flavors, because I think the media, and maybe all of us, we tend to paint AI as this singular monolith. People just say, the AI did this.
Which is about as useful as saying the vehicle moved. It tells you nothing. Was it a bicycle, a Ferrari, a freight train?
Exactly.
The source material breaks this down with a really helpful dichotomy right at the start. There is AI that follows rules, and there is AI that learns.
This is the distinction between rule-based AI and machine learning. And I think we tend to dismiss rule-based AI as like old tech, like it's the dinosaur in the room. But the book argues it's actually still crucial for specific contexts, right?
Oh, absolutely. Think of rule-based AI, or what the authors call follow-the-rules AI, as the bureaucrat of the digital world.
The bureaucrat. I like that.
It doesn't improvise. It doesn't get creative. It just follows a rigid if-then logic tree.
Yeah.
If X happens, you do Y, period.
Which sounds incredibly limiting if you're trying to write a novel, but I'm guessing that rigidity is actually the whole point in certain industries.
Precisely. Let's look at high-stakes environments. If you're monitoring a nuclear reactor core, or you're running a quality control line in a factory, looking for, microscopic cracks in a turbine blade.
You do not want it to get creative.
You do not want an AI that hallucinates or tries something new. You want 100% predictable consistency. You want the bureaucrat. You want it to look at the temperature gauge and say, if this goes 1 degree over, shut it down. No debate.
That makes perfect sense. You don't want the AI to ponder the philosophical implications of heat. You just want the safety protocol executed.
Right.
The source gave a more everyday example of this too, the old spam filters.
Yeah, remember the early 2000s. The old filters were purely rule-based. The code was literally written to say, if email contains Viagra, in all caps, then move to spam.
And that was it.
That was it. It didn't understand context. It just matched the pattern. It's auditable. It's transparent. But it's brittle. So if you misspell Viagra or, write it with spaces between the letters,
The rule breaks and the spam gets through.
the spam gets through, which brings us to the shift that changed everything, machine learning. This is where we stop programming rules and start programming the ability to learn rules.
Okay, so a layer of abstraction up.
Correct. Instead of writing the manual, we give the machine a ton of data and let it write its own manual. We're moving from explicit instruction to pattern recognition. The example the authors use is PXL-ident, a facial recognition system.
Right, because you couldn't possibly write a rule-based code for every face on Earth.
No way.
If nose is slightly crooked to the left and eyebrows are bushy, it would take forever to code that for 8 billion people.
It's impossible. So with machine learning, you just feed the system a million photos of faces. You don't tell it what a nose is. You don't tell it what an eye is. You just show it the data.
And it just figures it out.
Eventually, yeah. Statistically, it figures out that this specific arrangement of pixels usually correlates with face, and that this very specific variance in the pixels correlates with your face. It acquires knowledge.
Okay, so now within this machine learning universe, the book introduces 2 distinct learning styles. And I found this fascinating because it explains why some AI models are so expensive to build and others are, so chaotic. We have supervised learning and unsupervised learning. Let's break down the teacher model first.
Yeah.
Supervised.
Think of supervised learning as the classic classroom setting. You have the AI, which is the student, And you have the training data, which acts as the worksheet. But, and this is the crucial part, you also have the answer key.
The label.
Exactly, the labels. In supervised learning, humans have to intervene. We have to painstakingly label the data. This is a cat. This is a tumor. This is a fraudulent transaction.
So the AI makes a guess?
It makes a guess, it checks the answer key, and if it's wrong, it adjusts its internal math, its weights, to get closer to the right answer next time.
That sounds incredibly labor-intensive for the humans involved. I mean, someone has to sit there and label all that stuff.
It's the bottleneck.
Whoa.
It's why medical AI is so expensive and so difficult to develop. You need board-certified radiologists to sit there and label thousands upon thousands of x-rays so the machine can learn what a fracture actually looks like.
But the payoff is high precision, I assume.
Very high precision. It's why banks use this for fraud detection. They show the AI 10 years of transaction history. Here's what a normal purchase looks like. Here's what a stolen card looks like. The AI learns the boundary line because it was taught exactly where that line is.
Okay, so that's the disciplined student with the answer key. Then we have the explore unsupervised learning.
This is where you take away the answer key. You take away all the labels, you just dump the AI into a massive pile of raw, unlabeled data, and you say, find the structure.
It sounds like just asking for noise. How does it find anything useful if it doesn't even know what it's looking for?
It looks for mathematical similarities. It clusters things together. The book uses retail market segmentation as the prime example here. A human marketer, well, we have biases. We assume we should group customers by age or gender or zip code.
Right, the classic demographics. Millennials like avocado toast, Gen Z likes TikTok.
Exactly. We come in with these preconceived notions. But an unsupervised AI might look at raw purchasing data and find a totally weird cluster of people who buy high-end cheese, diapers, and AA batteries every Friday night.
And it has no idea why.
It has no idea why they do it or who they are, but it knows they are statistically identical in their behavior. It finds these tribes that humans would never see because we weren't looking for that specific weird combination.
That completely explains the uncannily accurate social media algorithms. They aren't programmed to know I like pottery videos. They just see that I fall into cluster 4000, which also just happens to like pottery videos.
It's strictly behavioral pattern matching on a scale our brains just can't comprehend. It finds the hidden structure in all the chaos.
So we have the learning styles, supervised and unsupervised. Now let's talk about the functional roles, because there's a huge difference between the AI that organizes my inbox and the AI that writes me a poem.
Yeah, a massive difference.
The book defines this as discriminative versus generative AI, or, as we put it in the outline, the organizer and the innovator.
The organizer and the innovator is the perfect way to frame it. Discriminative AI is all about drawing lines in the sand. It discriminates in the technical sense of the word between categories. Is this A or is it B?
Spam or not spam?
Is spam or not spam?
Yep.
Is this a picture of a hot dog or not a hot dog? It's taking the existing world and just sorting it into buckets for you.
And then generative AI is the one that's grabbing all the headlines right now?
Well, yeah, because it does something computers were never really supposed to be able to do, creation.
Right.
It takes all those learned patterns and it remixes them to generate a probability-based new thing, a new image, a new sentence, a new line of code. It's not sorting the data you have, it's expanding it.
But the real aha moment for me here wasn't just that they're different, it's how they interact. The movie recommendation example in the notes was a total light bulb moment for me. It's like a relay race between the two types.
It is. It's a feedback loop.
Yeah.
Think about it. If you want a movie recommendation, a generative model could, in theory, just hallucinate a list of movies based on general popularity.
Yeah.
It could just say, here are 10 movies that exist.
Which is not helpful at all.
Not helpful. So you need the discriminative model to step in.
The organizer.
The organizer steps in. It looks at your specific history, what you skipped, what you rated 5 stars, what you turned off after 10 minutes, and it filters that generative list down to the precise options you'll actually want to watch.
So the generator provides the possibilities and the discriminator provides the precision.
That's it. That's the partnership.
And the book mentions this applies to much bigger problems than what to watch on a Friday night, like climate change.
Oh, yeah. You could have generative AI imagining new solutions, say, modeling thousands of potential new molecular structures for carbon capture materials that don't even exist in nature yet. It's brainstorming at the speed of light.
Okay, so it's just throwing ideas at the wall.
And then you use discriminative AI to rigorously test those simulations against all known physics data to tell you which 1% of them are actually viable.
So it's the brainstorming phase versus the editing phase, just automated at supercomputer speeds.
That's the synergy. It's not about one replacing the other. It's about the loop between them.
Okay, so we know the flavors. Now I really want to look under the hood. We throw around terms like neural networks and NLP constantly, but the book actually breaks down the architecture. When we say neural network, we're using a biological metaphor, but it's really just, it's just math, isn't it?
It is layers and layers of math. A neural network is composed of nodes, which you can think of as little processing stations. And yeah, it's modeled loosely after neurons in the brain.
So how does it work?
Data comes in the input layer, say all the pixels of an image. Then it passes through what are called the hidden layers.
Hidden layers, that sounds mysterious.
It's just where the processing happens.
Yeah.
Think of each node like a little faucet. As the data flows through, the network learns to turn some faucets on full blast and shut others off based on all the training it's done.
Okay.
So if the network thinks a certain curve looks like an ear, the ear nodes light up and pass that signal forward. It's weighing the evidence at each layer. Finally, it all hits the output layer, which gives you the result. This is 98% likely a cat.
But the critical distinction the authors make, and this is where I think people get tripped up, is that the machine isn't seeing a cat. It doesn't know what a cat is. It's just processing a numerical probability.
That is the single most important concept to grasp, especially when we talk about natural language processing, or NLP. When you chat with an LLM, it feels like there's a consciousness on the other end, because the grammar is perfect, the prose is fluid.
It feels like it understands you.
It feels like it, but there is no understanding. It is a prediction machine.
It was essentially just autocomplete on steroids.
That's a great way to put it. It's just calculating the statistical probability of the next token, the next word or piece of a word. If I say the sky is, the model looks at its training data, which is essentially the entire internet.
Right.
And it calculates that blue has a 90% probability, gray has 9%, and sandwich has a 0.00001% probability.
Right.
It rolls the dice and picks a word based on that math.
This explains why it struggles with context sometimes. The book used the word play as an example.
Right. I went to see a play versus I want to play baseball. To a human, those are two totally different concepts. One is a noun, a theatrical performance. The other is a verb, a physical action.
But to the AI.
To an AI, it starts as the same string of letters, P-L-A-Y. It has to look at the context window, the surrounding words like theater or baseball, to assign the correct mathematical value to that token. It's solving a math equation where the variable is meaning.
And this leads us directly to the textbook analogy regarding training data. If the AI is just predicting based on what it's seen before,
then what it has seen matters more than anything else. The AI is only as good as the textbook it studied.
Yeah.
If you train a customer service bot on a textbook of angry, rude customer interactions from Reddit, guess what?
you're going to get a rude bot.
You're going to get a very rude, very unhelpful bot. This is the concept of garbage in, garbage out. The relevance and the quality of the training data are everything.
Yeah.
If you want an AI to understand medical jargon, you can't train it on Shakespeare. It needs to see thousands of specific questions and answers relevant to its job. It's a mirror of its data, not a crystal ball.
Which is a perfect segue to how this actually lands in the real world. This is our fourth part of the deep dive, the human-AI partnership. Because once you realize the AI is just a math machine predicting words based on a textbook, it becomes a lot less scary and a lot more of a tool.
We really need to reframe the narrative from replacement to augmentation. It's about supercharging human capability, not making humans obsolete.
Let's talk about healthcare again. The source mentions NVIDIA's MO&AI. This isn't some robot doctor replacing your GP.
No, absolutely not. MONAI is used to assist in medical imaging. Think of it as a superpowered second set of eyes for a radiologist.
Okay.
It can scan thousands of X-rays or MRIs in the time it takes a human to scan just one. It provides a first look or, an early detection service.
So it flags the weird stuff.
It flags the anomalies. It basically says, hey, doctor, you should really look at this specific area on slide 402. This allows the doctor to stop spending hours searching for the needle in the haystack and focus their energy on analyzing the needle and treating the patient.
It frees the human to do the human work.
The empathy, the complex judgment, all of that. Exactly.
And it's happening in education, too. There was a case study in the book about Nazareth University that I thought was really cool because it wasn't about students cheating on essays.
No, it was quite the opposite. This is a great example of upskilling. They integrated AI into experiential learning for their graduate students. Now, these weren't computer science majors.
Right.
These were students who needed to learn data analysis and coding for their future careers, but didn't have the technical background.
So they used AI to bridge that gap.
Exactly. They used AI to help them write the code or analyze the data sets. It allowed the students to function at a much higher level than their raw technical skills would have permitted them to otherwise.
Wow.
It prepared them for a workforce where being able to direct an AI is just as important as being able to do all the math yourself.
That's the future-proofing idea we'll come back to. It's also showing up in the workplace for, well, the boring stuff. I mean, nobody likes data entry.
And frankly, nobody should have to do it anymore. The source talks about automating mundane tasks to free up humans for creative problem solving. But there's also predictive maintenance in manufacturing.
Oh, this is like Minority Report for machines.
Ideally, yeah.
Yeah.
AI sensors can listen to a factory machine and detect these subtle changes in vibration or heat that predict a part is about to break weeks before it actually snaps.
So you fix it before the whole line shuts down.
Exactly. The efficiency, the safety, the cost saving, it's all about letting the machine handle the pattern recognition so the humans can handle the strategy.
Okay, so we're the pilots. Let's talk about the controls. We need to master the output.
Right.
And the book breaks this down into text, images, and audio. For text, it's not just write me an email.
No, there's a lot of nuance here. You have template-based generation, which is basically fill in the blanks, great for standardized reports, that kind of thing.
Okay.
Then you have freeform, which is your creative writing, your blog posts. But the really powerful business tool is natural language generation, or NLG.
This is taking raw numbers and turning them into a story, right?
Yes. A sophisticated NLG can take a spreadsheet of temperature, wind speed, and humidity data and write a paragraph that says, expect a breezy afternoon with cooling temperatures as a front moves in. It converts data into a narrative.
And executives love that because they don't want to read the spreadsheet.
They want the summary.
Speaking of summaries, there was a distinction in the book that just blew my mind. Extractive versus abstractive summarization. I had never realized these were two different technologies.
It's a critical distinction. Extractive summarization is like using a highlighter. The AI scans the document, finds what it thinks are the most important sentences based on keywords, and it just pulls them out verbatim.
So the summary is just a collage of the original text, no new words.
Correct. It's safe because it's using the author's exact words. But abstractive summarization, that's like a human assistant reading the entire document, understanding it, and then writing a completely new summary from scratch. It creates new sentences that capture the meaning, but might not use any of the exact phrasing from the original.
That feels much more advanced, but also riskier.
It is. It's much more useful for things like executive briefs, where you need actual synthesis, not just highlighting.
Mm-hmm.
But because it's generating new text based on probability, you have to verify it. It might hallucinate a detail that fits the vibe of the report, but wasn't actually there.
Right. Okay, let's talk visuals. We've got Midjourney, Stable Diffusion, DLE3. It feels like magic, but again, it all comes back to prompting.
It really does. Midjourney is known for those really artistic, highly detailed, almost photorealistic images. DLE3 is great because it's integrated with ChatGPT, so it's very conversational and easy to use.
And Stable Diffusion.
Stable Diffusion introduces a really cool concept the source highlights called negative prompting.
So telling it what not to do.
Exactly. Most people just prompt for what they want, draw a man in his suit. But negative prompting allows you to tell the AI what to subtract. Draw a man in a suit, but no tie, no hat, no blue.
You're sculpting the output by removing the variables you don't want.
It gives you so much more control. You're forcing the probability distribution away from those elements. If the AI knows cars are forbidden in a city scene, it has to fill that space with something else, maybe hovercrafts, maybe pedestrian walkways. It pushes the creativity of the model.
And then there's Adobe Firefly and Photoshop. This is less about make me a dragon and more about fixing reality, it seems.
Right. Image enhancement. Extending backgrounds, fixing old photos, removing unwanted objects. It's a workflow accelerator for designers. But we have to address the double edge that the book warns about.
The deepfakes, the Taylor Swift example.
Yes, the source mentions the fake Taylor Swift cookware endorsement that went viral. It's a stark reminder that as these tools get better at generating reality, our skepticism has to scale up with them. We literally can't believe our eyes anymore.
That is a scary thought. We can't believe our eyes, and we can't believe our ears either. The audio AI is getting wild.
It is. Text-to-speech, or TTS, has moved way beyond that robotic GPS voice from 10 years ago. The source mentions Speechify, which can clone a person's voice to read any text.
Which is really cool, but also deepfake territory again.
Potentially. But it's also incredibly useful for accessibility or content creation.
Hmm.
Imagine being able to listen to a long PDF report in a natural human voice on your commute.
That's a good point.
And then there's music, apps like MuseNet and Boomy.
I've played with Boomy. It's absolutely wild. You don't need to know a single chord.
Zero musical skill required. You just pick a mood, a style, and the AI generates the melody, the beat, even the lyrics, and a synthesized vocal track. It allows anyone to be a composer.
But this brings us to the final section of our dive, the strategies and limitations. Because anyone can be a composer and anyone can write a report. What are the pitfalls? What are the guardrails?
The biggest limitation, and the book is very, very clear on this, is EQ, emotional intelligence.
AI has none.
Zero. It cannot understand emotional subtleties or empathy. It can mimic them if it's seen them in the training data, but it doesn't feel them. It also really struggles with context and cultural nuance.
So it might say something that is technically correct but incredibly offensive or just tone deaf in a specific situation.
Exactly. And because of that garbage in, garbage out principle, if the training data has bias, the result will be biased. The source calls this the reality check. AI is not an objective arbiter of truth. It is a mirror of the data it was fed, biases and all.
And it lacks true creativity, right? We said it remixes, it doesn't invent.
It cannot engage in abstract thinking. It can't have a light bulb moment that comes from nowhere. It
Right.
can only connect dots that are already on the page that it was trained on.
So given all that, how do we win? What's the strategy for us, the pilots?
The strategy is the prompt. It all comes back to that. The foundation of success is the quality of your instructions.
Yeah.
You have to provide context, you have to define the audience, you have to specify the style.
So you can't just say, write a blog post.
You have to say, write a blog post about gardening for urban millennials who have never kept a plant alive in a humorous and encouraging tone under 500 words.
Specificity is king.
And iteration.
Yeah.
You have to refine, you look at the result, you see what's wrong with it, and you adjust the prompt. It's a conversation, not a vending machine.
I love that. A conversation, not a vending machine.
That's the whole takeaway.
So bringing it all together, we've gone from neural networks to Boomy. What's this? So what? What should you take away from all this?
The so what is that AI is a tool for future-proofing your career.
Yeah.
If you can offload the technical, the repetitive, and the data-heavy tasks to the AI, you free yourself up to be the strategist.
Yeah.
You become the empath. You become the one who adds the human context that the machine can never, ever fake.
You move from being the bricklayer to being the architect.
Precisely. That's the perfect analogy.
So I want to leave everyone with a thought to chew on. We talked about AI making art and music. If the AI handles the execution, the brush strokes, the chord progressions, what becomes the primary role of the human artist? Is art about the craft of doing it, or is it just about the idea? If I have a great idea and the AI paints it perfectly, am I the artist?
That is the philosophical question of the century, isn't it?
It is. Something to mull over while you experiment with Midjourney or Speechify tonight. Go get your hands dirty, become a pilot, and understand the machine. Thanks for diving deep with us.
It's been a pleasure.
See you next time.